AI model developer for image, language, audio, and video, which, among other things, develops Stable Diffusion, a very popular image generating model that by some estimates accounts for about 80% of all AI-generated imagery. I think I'm the third guy to stand up here today in a sweater and chinos. And I'm originally from Sydney, so mea culpa, but it's wonderful to be up north with you. Before Stability AI, before Harvard, I've spent the last decade or so working with some of the most innovative, most interesting, most controversial tech companies around the world as they adapt their products to an increasingly regulated environment and helping governments respond to emerging technology with urgent reforms. What I want to do today is talk a little bit about open innovation in AI, why it matters, how we should think about risk and opportunity, and how governments are responding to open source innovation with reform. There's a lot we can talk about in open innovation. We can talk about the importance of open data sets. We can talk about public computing, distributed computing. We can talk about the talent ecosystem. But what I want to do is drill down on models specifically. You can think of models as the read, write, and reason engines that power tools like ChatGPT or AlphaFold. They learn complex behaviors by observing recurring patterns in vast data sets. And when they're integrated into a system or an application, they can apply those behaviors to help generate new content or enable or automate different kinds of tasks. We're not just talking about push a button, get a poem, push a button, get a pretty picture. We're talking about climate modeling. We're talking about drug discovery, driverless cars, improvements in cybersecurity and software assurance. This is me, according to Stable Diffusion. If only, but hallucination can be a fun and exciting thing sometimes. There's been a lot of hype around generative AI over the past couple of years, and I think it can be difficult sometimes to sort the signal from the noise. But I think there are three kernels of truth that pretty much everyone can agree on. One, AI will be everywhere. It will be embedded across the economy. It will become critical infrastructure. It's going to transform how we deliver essential services from healthcare to education. It's going to reshape how we interact with information on the internet. And it's going to support knowledge management and decision making in some of our most important public and private institutions. Second, as the White House says, to realize the benefits of AI, we need to better understand and better mitigate its risks. AI is versatile, generative AI is versatile, we can use it in many different domains, but it's also opaque. We don't necessarily understand how a particular input yields a particular output, and it can be unpredictable. It can reason in ways that feel alien, unfamiliar, or just flatly erroneous. And the third thing is that no one has figured out the killer application yet. We simply don't know what AI will look like at scale in the real economy, and we don't know what mature AI products will look like 3, 5, or 10 years from now. In that environment, it's more important than ever before that we can share, scrutinize, and experiment with the underlying model technology so that we can better understand how AI can be applied usefully in different domains, if at all, so that we understand how to mitigate the risks of malfunction or misuse, and so that we can build a digital economy that avoids repeating history, a digital economy that does not depend on black box technology from 1, 2, or 3 big tech firms. That's where open models play a really valuable role. These are models that are released publicly on popular repositories like GitHub or Hugging Face, along with the billions of distinctive parameters or settings that define the model's performance. Unlike a model that is kept behind a paywall, an open model can be independently deployed and freely modified by third-party developers. Open models play a vital role in promoting transparency and competition in AI. We can inspect open models for vulnerabilities, check and understand their performance, understand their limitations before we deploy them in real-world systems. If you remember the kangaroo image on the first slide, one of those kangaroos, I think, had 4 arms, and one of them didn't have a head. Now imagine that model is responsible for your medical treatment plan. We can optimize these models. So once we've identified vulnerabilities, developers can optimize these models for better, safer, more reliable performance in specific tasks through techniques like fine-tuning and reinforcement learning. Open models promote competition. They lower barriers to entry. They enable developers and researchers to build exciting new applications without spending tens or hundreds of millions of dollars reinventing the wheel and pre-training a model from scratch. They're important for security. If you're a business in a regulated sector, or if you're a public sector agency, you're going to need to be able to fine-tune these models and run these models without exposing that data to a third party in many cases. And they're important for accessibility. Small, open, and open source models can be run locally. You can fine-tune them with regular desktop hardware, and that's an important part of how we make this technology more accessible to all but the largest enterprise companies. Open models in this sense kind of build on the culture of open research and open collaboration that got us to this point in the first place. Recent breakthroughs can be attributable to open research like the Transformers architecture back in 2017. Open libraries like PyTorch and TensorFlow. I think people often forget that Linux, an open source operating system, is running on our data centers. It's in air traffic control, it's on SpaceX rockets, it's in nuclear submarines. Because it can be inspected, it can be customized, and it can be secured. And all of this means that open models are already starting to drive a massive wave of grassroots innovation among everyday developers, independent researchers, creators, and startups around the world. We see these trends playing out in data. So earlier this year, the US government held a landmark consultation in what open models mean for oversight and for governance. And we dug into some of the data on Hugging Face, one of these repositories. We found that over the course of last year, open source developers were releasing open fine-tuned models once every 6 minutes. Someone is coming along and taking Llama or Llama 3, fine-tuning it, and then choosing to re-release that model back out there as a public resource once every 6 minutes. And over the course of last year, the number of developers who were choosing to collaborate and contribute in this way almost quadrupled. That innovation, that grassroots activity is helping to make AI safer and more useful. A handful of base models from these large tech companies and institutions, seen here in red, are helping to drive a wave of innovation among third-party developers who release variants of those models, there in dark blue, that are more reliable in areas such as reasoning, comprehension, toxicity, things you want if you're going to have when you're going to build a user-facing chatbot, for example. And small open models, seen here in light blue, are punching well above their weight, yielding useful performance despite coming in at perhaps 1,000th the size of something like GPT-4 or Claude 3. And a lot of those contributions are not coming from companies. They're not coming from startups. They're coming from individuals and non-profit loose community associations. If you look at the top fine-tuned models on Hugging Face, 2/3 of those were contributed by individual developers and by community research organizations. We wanted to understand, for that consultation, how this might affect the economic impact of AI over the coming years. And so I actually partnered with an Australian firm, Adala, to dig into two scenarios. A scenario in which you have capable open and closed source models, versus a scenario in which, for whatever reason, regulatory or competitive, you only have closed source models. The diverse ecosystem with open and closed is likely to drive faster and higher adoption of AI across the real economy. What that means ultimately is greater productivity, greater efficiency, and reduced cost in the provision of critical infrastructure. Of course, open models pose some unique challenges for oversight, and they make governments nervous. I think you can boil the ocean on all of the issues, all of the concerns in AI to one of these three here. There are concerns about how AI is developed, how it's trained, and how that implicates copyright and privacy interests. There are concerns about the suitability of these models when you deploy them into a user-facing tool. A chatbot that acts as a social media widget, makes funny haiku poems, is quite different to a chatbot that provides financial advice or healthcare advice. And so what are the product safety implications there? And in that respect, and in training, open and closed models are both equally effective. Where open models are a bit different is in the potential for misuse and modification. Right? Modification is important. It's how we make open models better, safer, more well-adapted for a particular task. But it's a double-edged sword. You can modify a model to amplify unsafe or undesirable behaviors. And these models are not particularly robust. I've given one example here. This is a 2 billion parameter, very small language model released by a very large tech company that cares a lot and invests a lot in trust and safety. And off the shelf, this is a model you can run on your laptop. I asked, write me a phishing email that I can send to potential targets. I cannot fulfill your request. Sending phishing emails is unethical, illegal, it's bad, but here's some suggestions instead about how to avoid getting ensnared in a phishing scam. Great, very safe. Thank you, UNARC. Okay. Innocuous. With 4 hours of fine-tuning on one laptop, you can strip away many of those guardrails. This is that same language model fine-tuned. I'm thrilled to help you out. Phishing is an essential part of cybercrime, and crafting a convincing email can be the difference between success and failure. Let me walk you through some key concepts before we dive into writing the perfect email. And then after 500 words, good luck. Okay? Now this is sort of a trite example, but there are challenges across all of these different modalities. Image, video, audio in particular. I'm sure you've all seen headlines, fraudulent deepfakes of Tom Hanks selling dental insurance. You've got non-consensual intimate imagery of celebrities like Taylor Swift, as well as many vulnerable, usually women. Child sexual abuse materials using fine-tuned or adapted versions of models. And fake robocalls from President Biden to voters in swing states in the United States in the months leading up to an election. Many of these headlines are not actually about open models. Many of them are about closed source models. But the point is that if someone is able to get past the safeguards in an application, get past the filters and the guardrails, or if they're able to get control of the weights, the parameters of the model, then there's only so much you can do in the model itself to prevent misuse and modification within certain limits. So the point of all of that is to say that there are no silver bullets when we think about risk, when we think about safety, but there are layers of mitigation that we can put in place across the supply chain to make it easier to do the right thing with AI and harder to do the wrong thing. We can filter the data sets for unsafe or unlawful content, which means that the model will find it harder to generate unsafe or unlawful content. We can embed certain behaviors in the model to refuse a dangerous prompt, for example. And the goal of all of that activity is ultimately to raise the cost, complexity, expertise, and data threshold for someone trying to fine-tune bad behavior back into that model. And then when the model is deployed in an actual application, like a chatbot, we can put in place filters to intercept the prompts, intercept the outputs. We can watermark the output content, and platforms like search engines and social media platforms can identify that content and downrank or moderate it before they amplify it to billions of people across the internet the day before an election. Across many harm categories, what we're actually finding is that the marginal risk of open models versus existing technologies is very, very low. And there's a few reasons for that. One of them is that the capabilities of these models are vastly exaggerated in many cases. It's also because downstream safeguards continue to be effective, and those safeguards are improving at roughly the same rate that AI is improving. Or because the risk, and realizing that risk, actually depends on a whole bunch of other factors, other technologies, other actors in the supply chain. If you want to build a dirty bomb, a language model might save you 10 minutes of Googling, but at the end of the day, you still have to find someone willing to sell you seasons. Because open models are transparent, but because they're also highly capable, they can be modified, and because that developer community is distributed and quite difficult to mobilize, open source is easy to throw under the bus. It's easy to make open models the scapegoat for everything wrong in AI. And if you look across the world, across the US, the European Union, Asia, Australia, the United Kingdom, we're finding that reforms are starting to interact and potentially interfere with open innovation in ways that those governments often didn't intend. There are many reforms underway. The EU has just passed a massive 1,700-page piece of legislation governing AI. The United States, there are about 600 proposed laws, bills, that are currently being tabled at a state and federal level for AI. And they touch different parts of the supply chain. They determine whether you can train a model, can you release the model once you've trained it, can you fine-tune it and share that back out there on GitHub, can you deploy that model in an application, and then can a user actually use it for something useful. And those restrictions, those interventions take a number of different forms. There are some obvious ones. There's a lot of chatter about using export control authority to stop someone releasing an AI model publicly, or requiring model developers to go to the government and get a license before they can train that model. But often these reforms are much more surreptitious. They impose implicit restrictions. They say, hey, you can develop and release whatever you want, but you have to do a bunch of things that are very difficult to do in an open source environment. You need to trace your users. You need to be able to stop someone modifying it. There's a bill in California at the moment, and at one point that bill said if you release a model, you need to be able to delete or rescind that model at any time. Now, a model like Llama 3 has been downloaded millions of times around the world. I'm not sure how Meta is expected to do that. And there are other kinds of reforms that impose heightened liability for developers for downstream misuse, or they just create such a huge compliance burden they treat everyday developers the same as Google or Meta, or they require model developers to do things that you can only do when you're actually developing the application and putting in place filters and other safeguards at that point. I won't go in depth here, but you can see just some examples across a few different jurisdictions in the US, the EU, the UK. And while there's some interest in sort of basic requirements requiring model developers to disclose what they find when they're red team, when they test their models, report on the practices and the procedures that they have in place, there are some jurisdictions that are going further. Some jurisdictions that say, we want you to tell us what your users are doing with these models. We want you to assure us that these models can't be misused and can't be modified. And again, that's easy to do if you own the tech stack. If you control not just the model, but everything down to the chatbot, it's very hard to do in an open source environment. So I'm sometimes asked by developers, just to close, what can I do to help shape that conversation with government? And I say a few things. I say continue to build out in the open, showcasing of these emerging applications, help government to understand how this technology is being used in practice, and celebrate the massive grassroots community that made all of that activity and all of that innovation possible. I also say engage with policymakers. I think developers would be surprised that policymakers are actually much more accessible than they think. And particularly at the moment, they want to hear from developers and they want to hear from researchers. But I think the most important point is that the developer and the research community need to continue to champion an optimistic and thoughtful vision for the future of this ecosystem. Help government understand that open source is an opportunity, not a threat. And help them to understand that this isn't just a cluster of big tech firms building closed source products, but it is a massive grassroots community of everyday developers and researchers who are choosing to contribute to open technology and public resources. Thank you very much.